Today we are going to continue talking about solving trig equations. By the end of this video, you should be able to solve trigonometric equations on the interval 0 to 2 pi. Let's take a look at our first example. We have 2 cosine of 3t minus 1 equals 0. So first we're going to isolate cosine of 3t, so we're going to add 1 and divide by 2, which gives us cosine of 3t equals 1/2. Now we need to look at the unit circle. Where is cosine 1/2? Well, that occurs at pi over 3 and 5 pi over 3. So we have 3t equals pi over 3 and 3t equals 5 pi over 3. So when we divide by 3, we end up with t equals pi over 9 and t equals 5 pi over 9. We want all of the solutions that are on the interval 0 to 2 pi. These values are not anywhere close to 2 pi, so we need to continue looking at coterminal angles to figure out if there are other solutions. So I'm going to take pi over 3 and add 2 pi. And 2 pi is 6 pi over 3. So I'm going to add 6 pi over 3 to both of these. And if I solve these, I have 7 pi over 9 and 11 pi over 9. Well, 11 pi over 9 is a little more than 2 pi, so I'm going to go around the unit circle one more time. So if I add 6 pi over 3 again, I get 13 pi over 3 and 17 pi over 3. So when I solve these, I end up with 13 pi over 9 and 17 pi over 9. 17 pi over 9 is just under 2 pi, so that is probably our last answer. But if we look at the next angle, so if I add 6 pi over 3 again, that would give me 19 pi over 3, which would give me 19 pi over 9, which is more than 2 pi. So that will not be one of our solutions. So we just have these 6 solutions that are between 0 and 2 pi. Now, if you notice, we had cosine of 3t, and we had to go around the unit circle 3 times to find all of our solutions. Let's look at the next one. Here we have 3 tangent of x over 2 plus 3 equals 0. So I'm going to isolate tangent of x over 2. So if I subtract 3 and then divide by 3, I end up with tangent of x over 2 equals -1. So if I look at the unit circle, where does tangent equal -1? Here and here. So I have x over 2 equals 3 pi over 4, and x over 2 equals 7 pi over 4. Then I need to multiply by 2. So I get 3 pi over 2 and 7 pi over 2. Well, 7 pi over 2 is not between 0 and 2 pi, so my only answer is 3 pi over 2. Let's continue. Here I have cosine of x plus 1 equals sine of x. Well, we don't have any identities that can help us yet. I'm going to start by squaring both sides, and then I'll be able to use some identities so that I only have cosine or I only have sine. When you decide to square both sides of an equation, you have to be careful because you will have to check for extraneous solutions. So when I square the left side of this equation, you have to remember to FOIL this out. So I end up with cosine squared of x plus 2 cosine of x plus 1. And on the right side of the equation, I just have sine squared of x. I'm going to use my Pythagorean identities to change sine squared of x to 1 minus cosine squared of x. That way I only have cosines in my equation. Then I'm going to set this equation equal to 0. Now I can factor and solve. If I factor out 2 cosine of x, I end up with cosine of x plus 1. So now I can say cosine of x equals 0 and cosine of x equals negative 1. Then I just need to look at the unit circle. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. And cosine of x is equal to negative 1 at pi. So right now I have x equals pi over 2, pi, and 3 pi over 2. But I have to go back to the original problem and check for extraneous solutions. You can use your calculator for this, or you can figure it out using the unit circle. So if I plug pi over 2 back into this equation, I have cosine of pi over 2, which is 0, plus 1 is 1. Sine of pi over 2 is 1. So pi over 2 works. Let me check pi. Cosine of pi is negative 1, plus 1 is 0. And sine of pi is 0. So that one works as well. If I check 3 pi over 2, cosine of 3 pi over 2 is 0, plus 1 is 1. But sine of 3 pi over 2 is negative 1. So this is an extraneous solution. And my only solutions are pi over 2 and pi. Next, I have secant squared of x minus 2 tangent of x equals 4. I can use my Pythagorean identities to change secant squared of x to tangent squared of x plus 1. Then I want to set this equal to 0. So I have tangent squared of x minus 2 tangent of x minus 3 equals 0. Then I need to factor. So I have tangent of x minus 3 times tangent of x plus 1 equals 0. So tangent of x equals 3, tangent of x equals negative 1. If I look at the unit circle, tangent of x is equal to negative 1 at 3 pi over 4 and 7 pi over 4. Tangent of x equals 3 is not on the unit circle, but that doesn't mean that it doesn't exist. So if I have x equals inverse tangent of 3, and I plug that in the calculator, inverse tangent of 3, I get 1.249. Now, since this gave me a decimal, 1.249 radians is somewhere around here. There is another value on the unit circle that will have a tangent of 3, and that is here-ish. We need to add pi to the value that the calculator gave us to get the second answer. So if I go back to my calculator and hit plus pi, I get 4.391. So I actually have 4 answers to this equation. Let's take a look at one last problem. I have x equals 2 sine of x. If I start by setting this equal to 0, there's not a good algebraic way to figure this out. So I'm going to go to Desmos and graph this. And remember that I am looking for the x-intercepts. So if I have 2 sine of x minus x, make sure that you're in radian mode. If you click the wrench in the corner, radians should be highlighted in green. And then you can click on the x-intercepts. So we have negative 1.895, 0, and 1.895. Now, negative 1.895 is not between 0 and 2 pi, so we just need these two answers.